Welcome to solverfy.
In this question, we're told about the concentration of CO in air is 3.5 parts per million, and we are told to calculate the number of CO molecule in 1.0 liter volume at a pressure of 759 torr and temperature of 22 degrees Celsius. So we need to do a couple of conversion before we go straight into the calculation. So first, we know that 1 torr is 0.0013579 atmosphere. Therefore, 759 torr will be equals to this number of atmosphere. Just multiply that by 759 by this number to get this. And also temperature was given to be 22 degrees Celsius, so we convert that to Kelvin. That will be 22 plus 273, all in Kelvin, 0.15. That will give us 295.15 Kelvin. Okay. Now, we know PV is equals to nRT, and N is then equals to PV over RT. Since we know the pressure, we know the volume, we know the gas constant, and we know the temperature. So put all those into the equation. We have P to be 0.99 atmosphere multiplied by volume 1.0 liter multiplied by gas constant 0.0820 liter atmosphere per mole per Kelvin multiplied by temperature, which is 291.5 Kelvin. And that will give us 0.00413 mole. So that's the number of mole. Now, we can calculate the number of mole of CO. Since we are given the concentration of CO in the atmosphere to be 3.5 parts per million, that means that we have the number of molecule of CO, number of mole of CO will then be number of mole of air multiplied by the 3.5 mole of CO and 10 raised to the power 6 mole of air. Since 1 part per million is 1 part in 1 million, right? So if we have 3.5 parts per million, that means we have 3.5 parts in 1 million. So if we have, that is still the same thing as having 3.5 mole in 10 to the power 6 mole. So that's 0.5 ppm. So 3.5 mole of CO in 1 million mole of air. Okay, so now the number of mole of CO would then be equals to number of mole of air, calculated to be 0.0413 mole, multiplied by 3.5 mole of CO divided by 10 to the power 6 mole of air. So all this gives us, this would be 0.0413 times 3.5 divided by 10 to the power 6. So this would give us number of mole of CO to be equals to 1.45 times 10 to the power minus 7 mole of CO. But then we know that 1 mole of a substance contains 6.02 times 10 to the power 23 molecules. Therefore, if we have 1.45 times 10 to the power minus 7 mole, we can calculate the number of molecules. So 1.45 times 10 to the power minus 7 mole of CO will be equivalent to 6.02 times 10 to the power 23 molecules multiplied by 1.45 times 10 to the power minus 7 mole divided by 1.4 divided by 1.0 mole. And this would be 8.70 times 10 raised to power 16 molecules.